Hey everyone, hope you're doing well today. In this video, I'm just going to do a little video answer key for this Unit 1 Homework 10, just some applications on multiplying fractions. So let's kind of get right into it. This first question is asking us to determine the product of these two numbers. Keep in mind product means multiplication, so I'm going to get right into showing that multiplication problem, multiplying these two fractions of 2/3, and we're going to find the product of that with 3/4. And it says use a rectangular model / diagram to justify the answer. Well, let's go ahead and just multiply normally first. If we multiply, we can just do some cross canceling, right? This 2 and 4 both have 2 in common. That becomes 1 and 2. And then this 3 and 3 can cross cancel to make 1 and 1. So then if we go ahead and multiply this 1 times 1, that's going to be a 1 on top, and then 1 times 1 on, or 1 times 2 on bottom rather, is going to be 1/2. So this final answer here is going to be 1/2. That's the answer to this multiplication problem. That's the product. Now, if they're asking us to use some sort of rectangular model, here's one way we can show that. For one way, let me just go ahead and draw a rectangle. I'm going to draw it so that it has 4 boxes going down, and then I'm going to go into thirds. So I'll go 2, 4, 6. That's a multiple of 3. So I can show the 2/3 easier. So let me show you if this makes sense. I chose 6 boxes to go across so that I can go 2 boxes for each column. So it does say 2/3 here. So I'm going to go ahead and show that this right here is 2/3. And I'm going to shade in 2 out of these 3. So here's 1/3 and here's the 2/3. All right, so that's going to be the 2/3. And then let's maybe take a look at the 3/4 now. So I chose to go 4 boxes down. Oops, I guess I'll use this, so that I could go ahead and draw 4 total rows across. So 3 lines gets us, those 4 rows. So I'm going to go ahead and show that 3/4 would be 3 of these, right? So here's 1/4 going all the way across. Here's 2/4 going all the way across. And then here's 3/4 going all the way across. Okay, so this would be a great area model. And then how can we kind of show our solution here? Well, how many of these boxes got shaded twice? So that's 3, 4, 5, 6. There were 6 of these that got shaded twice out of the 12 total of these boxes. And that simplifies down to 1/2. So this does work out. So again, when you do the area models, you can do the multiplication or division and see what your answer is, and then you can use the model to kind of back yourself up. So hopefully this also proves from the model that 2/3 times 3/4 is equal to 1/2. All right, that's number 1. Number 2, let me move this down. Landon walks 4/5 of a kilometer today, and then tomorrow he's going to walk 5/6 of that distance. So let's go ahead and try that out. So we know he walks 4/5 today, and tomorrow he's going to be walking 5/6 of that. So we need to find 5/6 of, I keep forgetting these fractions, they're so small, 5/6 of the 4/5. Okay, so tomorrow he's going to be walking less because he's not walking all of what he walked today. He's only walking 5/6 of that amount. So important word to know in math is of. This of means we're going to be multiply. So if it's going to be 5/6 of it, we're going to do 5/6 multiplied by 4/5. And you can totally look to see if you can cross cancel here, which I'm going to do. So if we take a look here, this 5 and 5 definitely cross cancel to make 1 and 1. And then this 6 and 4 can cross cancel by 2 to make 2 and 3. And then if we just multiply this 1 times 2 on top, that would be 2. And then this 3 times 1 on bottom would equal 3. So tomorrow, Landon's going to walk 2/3 of a kilometer. So we can write our final answer as 2/3 kilometers, or km, tomorrow. That's how much Landon will walk. Okay, so that would be number 2. Just keep in mind the word of means multiply, so hopefully that makes a little bit more sense. Moving on to number 3. Emma eats, what is this, 5/6 of a pizza per day. How much does she end up eating in 3.5 days? So let's see. one way you can think about this is she's eating 5/6 on the first day, and then she's going to eat 5/6 on the second day, and on the third day she's going to eat 5/6, and then for the next half a day she can't eat the whole 5/6, so she would have to eat half of the 5/6 on that last day. So this is one way to think about it. If you want to solve this, you could totally do that. But maybe the quicker way is saying, okay, well, you're doing something over and over again, so that would mean that we're doing some repetition. And when you repeat things, that means you are just multiplying. So this is 5/6 times 3.5. Again, to take this and write it as an improper fraction, we can write 5/6 times, and then 3 times 2 is 6, plus 1 is 7. So that would be 7/2. And then I don't think we can cross cancel, so 7 times 5 is 35, and then 6 times 2 is going to be 12. And 12 goes into 35 how many times? Goes in 2 times, that's 24, and then we have 11 left over, so 2 and 11/12. So she's going to have 2 and 11/12. What are we talking about here? Pizzas total. So that's how many pizzas she'll eat during that time if she's eating 5/6 of a pizza each day. All right, so that's number 3. For number 4, we have this volume question, and you're given the dimensions of it. So I can kind of draw maybe a quick rectangular prism just to kind of show you what this looks like. So rectangular prism is just like any shoebox. There's an email. And so I'm just going to go ahead and draw one of these packages. Maybe it's like an Amazon Prime or some other package you get in the mail. Looks something like this. And we're told that we have 3.5 for the length. I'm going to put that down here. 3.5 going across. And then 2 1/4. 2 1/4 going back here. And then 6 3/4 going up and down. 6 3/4 coming up and down. So we're asked to find the volume of this thing. And so volume is pretty straightforward for all rectangular prisms. So volume is going to be equal to the length times the width times the height. It's kind of given in the problem over to the left. You can take a peek. So to figure out the volume, you just have to take the length, which is 3.5, multiply by the width, which is 2 1/4, and then multiply that by the height, whoopsies, which is going to be 6 3/4. So turning these into some improper fractions, 3 times 2 is 6, plus 1 is 7. So that's going to be 7/2. Then for this next one, 2 times 4 is 8, plus 1 is 9. So it's going to be times 9/4. And then 6 times 4 is 24, plus 3 is 27. So this will be 27/4. Now this one looks pretty bad because we can't cross cancel. I don't see anything in common. So 7 times 9 on top is 63. 63 times 27. That should be 1,701. And on bottom, 2 times 4 is 8, times 4 is 32. Now, how many times does 32 go into 1701? Not 60 times. I think more in the 50s. Should be 53, I believe. I guess I can double check this instead of being lazy right now. 1701 divided by 32. This does go in 5 times. That's 160. I know that. And then that's going to be 10 with a 1. So that's the 3. That's the 96 I was thinking of. I guess the remainder here is 5. So it's going to be 53 and 5 30-seconds. This would be the volume, and this is in meters cubed. So again, volume is a 3-dimensional measurement, so we should have cubic meters as our unit. All right, there's number 4. Number 5, Elias drinks 2.5 cups of lemonade per hour. Okay, that's a rate. How much does he drink in 3 3/4 hours? So this is the one kind of similar to Emma, where she was eating the pizza each day. But now it's Elias, and we're talking about lemonade. So let's give this a try. So I'll put number 5 maybe right over here. And I'm just going to go right into the multiplication. So it's just 2.5, and he does this each hour for 3 3/4 hours. Oops, it's 3 3/4. Sorry about that. And then so we need to turn improper fractions. So 2 times 2 is 4 plus 1. That's going to be 5. 5 over 2. And then 3 times 4 is 12 plus 3. That's going to be 15. So this should be 15 over 4. Unfortunately, I don't think we can cross cancel. So 15 times 5 or 5 times 15 is 75. And then 2 times 4 is going to be 8. And I know 8 times 9 is 72 with 3 left over. So 9 3/8. So what are we measuring this? This is 9 3/8, 9 3/8 cups. That's cups of lemonade, right? So if you want to specify, go for it. But I think for right now, this should be detailed enough. Okay, that's number 5. Number 6, create and solve your own word problem that involves multiplying proper fractions. I'm going to say, today, Miss Jaeger ate 7/8 of a bag of fruit snacks. Okay, so she didn't eat an entire bag. She ate 7/8 of a bag. I'm going to say tomorrow, Mr. Lee eats half that amount. How much? Whoops. How much did Mr. Lee eat? Okay, so that would be a problem. So we could say, well, if Mr. Lee ate half of that amount, what was that amount? That was that Miss Jaeger ate, so that would be 1/2 of, or I can write this out, it's be 1/2 of that 7/8. These are both proper fractions. And so as a math problem, that'd be 1/2 times 7/8. And if you answer that, that'd be 7/16. This would be of a bag. Right, so if Miss Jaeger ate 7/8 and I ate half of that amount the next day, half of 7/8 is 7/16. Okay, so that would be an example of a word problem that I created that involves multiplying proper fractions. All right, number 7. Rudu has a garden that is 8 2/3 feet by 12 3/4. What's the area of this garden? Okay, so I'm just going to go ahead and draw a rough sketch of this beautiful garden. The measurements are pretty close, so do something like this maybe. Let's say 8 2/3. That's the shorter side of this garden. That's how long that is. And then another dimension is 12 3/4. Okay, so it says find the area. So how do we find the area of a rectangle? Area is going to be length times width. And in this case, we know the length is 12 3/4. And we know the width is 8 2/3. If we turn these to impropers, 12 times 4 is 48 plus 3. That'll be 51 over 4. And I guess I can make this a little bigger, right? Let's see, 8 times 3 is 24 plus 2. That's going to be 26. So 26 over 3. Ooh, I think I can see some cross-canceling here. So 4 and 26, you can divide them both by 2. We'll get 2, and we'll get 13. And I see one more thing here. 3 and 51. Remember, 5 plus 1 is 6, so it's divisible by 3. So that's going to be 1, and that's going to be 17. So not the best, not the worst. We could cross-cancel a little bit here. On top, what are we left with here? We have 17 times 13, and on bottom we have 2 times 1. So 17 times 13, I think, is 221, 221, and 2 times 1 is 2. And so this should be, what, 110 and a half. And what do we have here? Square feet, feet squared. I think that would be the area here of Rudy's garden. Okay, 110 and a half feet squared. That's number 7. Let's go on to number 8. Last couple, a little bit shorter of a set of practice problems here. CC is filling up a fish tank but can only carry 1 7/8 gallons of water each trip. If she's making 12 trips, how much total water does she end up putting in the tank? So again, this is repetition. Any question that's dealing with things repeating over and over again is a generally multiplication question. And so here's our original problem. And then we should try to multiply it, but we need to convert this 1 7/8 to improper. Okay, so 1 times 8 is 8, and then plus that 7, that's going to be 15. So I'm going to write 15 over 8 times 12, and as 12 as a improper is 12 over 1. Okay, looking to cross cancel 12 and 8, you can divide both by 4. We'll get 2 and 3. And then what do we have here? 15 times 3, and then 2 times 1. So that'll be 45 over 2. And if we turn that to a mixed number, 2 goes into that 22 times. That's 44, right? With 1 left over. So this is going to be 22 and a half gallons, I think, would be the total. So if she made this amount of trips, 12 trips, and each time she brought 1 7/8 gallons in total, she'll have brought 22 and a half gallons here. Okay, that's what we just found out. So that's number 8. Number 9, Julia watches YouTube for that many hours, and she watched 8 4/5 videos per hour. So how many total videos did she watch? So this is another repetition problem. So hopefully after this set of practice problems, you feel a lot better about multiplying and some context. Okay, so multiplying to figure out how many hours of videos she actually watched. And so it's a multiplication problem. So we're going to multiply and add. 3 times 4 is 12. 12 plus 1 is 13. So it's 13 over 4. And then 8 times 5 is 40 plus 4 is going to be 44 over 5. Any cross canceling? Yeah, I think so. These two can cross cancel. That's a 1 and that's an 11. And so if you multiply these two on top and multiply these two on bottom, I'm thinking here 13 times 11, that's what, 143, I think? 143 over 5. And dividing that down, I think that goes in 28 times. I think that's, whoopsies, I guess it doesn't matter what color I use, but I think this is going to be 28 and 3/5. Oh, that's videos, not hours. I think I said hours earlier. So she wouldn't quite finish watching her 29th video, but she would watch 28 and 3/5 of a video. And if you're wondering how I got this 28 and 3/5, just keep in mind that you can do long division. So if you divide here, that would be 2, that would be 10, that's a 4, that's a 3, that's an 8, that's a 40, and the remainder is 3. So that does check out of 28 and 3/5. All right, so there's the 9 different practice problems that you were hopefully trying out on your own, but hopefully this answer key made you feel a little bit better. And let me try just doing those answer keys a little bit here. Okay, so I forgot updates down here as I'm doing it. Oh, that's cool. I guess you learned something, right? Okay, for number 10, it says find the surface area of a rectangular prism that has these dimensions. So what you're supposed to do for this type of problem is maybe I can sketch it out and so you can see it. There's different formulas you can use. I guess I'll try to use the most direct way that I think you'll understand this problem. So I'll draw a rectangular prism first and then explain like what I guess surface area is if you're not sure. It's kind of satisfying to draw these. So 3.5. All right, so I'm gonna put 5.5 or 5 1/3 along the longest side. I'm gonna put 4 2/3 as the height. None of that really matters though, as long as you have all three measurements on there. And so they say find the surface area, and the surface area is really the area of all the surfaces combined, right? So let's see if we were to lay this out. On the bottom, if we were to lay this out, let's call the bottom 5 1/3 by 3 1/2. Okay, that's the bottom. But keep in mind that these prisms, there's two of them, of two of each side, because if there's a bottom, there's also a top. Okay, now there's the bottom and there's the top. In terms of the front, let's call the front here. The front, we know is 5 1/3 by 4 2/3. Is that right? The front is 5 1/3 by 4 2/3. Yeah, that makes sense to me. And so if that's the front, that's also the back. Keep in mind the front and back are the same thing. And then the left and right side. The left side and right side are 3 1/2 by 4 2/3. So let's go ahead and write that in. Whoops. So this would be 3 1/2. And we should have that on the other side as well, another 3 1/2. So basically what have I done here? I've taken the box and I've kind of deconstructed it. And what you're supposed to do is find the area of each of these sides and then add them all up. That would get you the surface area. Okay, so maybe I'll start with the green ones first. So for the green ones to find the area, what you would do first is you would do 3 1/2 and multiply that by 4 2/3. But remember, you would take this answer and multiply it by 2 because there's two of these shapes. Okay, so I'm going to turn that into an improper and turn this into an improper. And if I do that, that'll be 7/2 times, this will be 12, 13, 14/3 times 2/1. These 2's can cross cancel, become 1's. And what do we have left? We have 7 times 14 on top times 1. So 7 times 14 is 98 times 1 is still 98. And on the bottom we have 1 times 3 times 1, and that is going to be 3. So how many times does 98 go into, or 3 go into 98? I think it's 23 times. 23, not 23, 32. I switched the numbers in my head. 32 gets you 96, and then 2/3, and this is going to be inches squared. So this isn't the answer, but this gets you the area of the two green pieces, okay? As for the orange pieces, the area for those, what are the dimensions of the orange rectangles? It's gonna be 4 2/3 times 5 1/3. I think those are the dimensions, and you're gonna multiply this by 2 because there's two of them. So let's turn these into improper. So 4 times 3 is 12 plus 2 is 14/3. 5 times 3 is 15 plus 1 is going to be 16/3. And then times 2/1 is just going to be 2/1. I don't think anything can cross cancel, sorry. 14 times 16 times 2. I think that's 224 times 2, 448. I think it's gonna be 448, and on the bottom that should be 9. So turning this into a mixed number, 9 times 5 is 45, so that's 50. 9 times 50 is 450. So this has got to be 49 with 7 left over. Yeah, 50 times 9 is 450, 2 left over. So 49 and 7/9 inches squared. That would be the area of the two orange pieces. Okay. For the area of the two black rectangles that I have, so I did the green, I did the orange, I'm doing the black now. The black rectangles are going to be 5 1/3 and 3 1/2. Those are its dimensions. And there are two of them, so make sure we multiply this by 2. 5 times 3 is 15 plus 1. It's going to be 16/3 3 times 2 is 6 plus 1 is 7, so that's going to be 7 over 2, and then times 2 over 1. I'm going to cross cancel these 2's, I like getting rid of the matching ones. And then on top 16 times 7, that's 70 plus 42, so I think it's 112. And on the bottom 3 times 1 times 1. So just getting what's 112 on top divided by 3. And I think that goes in 37 times, if I'm not mistaken. 37 with 1 left over. So that's inches squared. Okay, so let's go ahead and see if we can combine some stuff here. So if we take this piece and add it to this piece and add it to this piece, adding fractions is not too bad. We can leave them as mixed numbers if we'd like to. So let's go ahead and write this 32 and 2/3. Actually, let's make everything ninths right now. So times 3 times 3. That's 32 and 6/9 plus 49 and 7/9 plus 37. Instead of 1/3, I'm going to write 3/9 times 3 times 3. So what's nice is I'm just going to go ahead and add the whole numbers together. So 32 plus 49, that should be 81, plus 37, that's going to be 118. So 118, and then how many ninths do we have? 6 plus 7 is 13, plus 3 is 16. And then so this is an improper inside of a mixed number, so we should have 119 and 7/9 inches squared. This should be the correct surface area for this rectangular prism. All right. So there is number 10. That one is kind of a long problem. Hopefully number 11 isn't as bad. Let's see. Number 11. We have to simplify this thing. So we have 5x over 8 plus 2x over 3 times 6 over 2x minus 4x over 12. Okay, so a little order of operations, but the first thing we have to do is focusing on this section here. Multiplication's most important. We can actually cross cancel a little bit here. So 3 and 6 become 1 and 2. And then this 2 and 2 can cross cancel with each other to make 1 and 1. And then this lovely x and x can also cross cancel with each other, and those go away as well. So the only thing we have left in the middle is actually, let's see, let's clean this up. We have 2 times 1 on top and 1 times 1 on bottom. So we have 2 over 1, which is just 2, which is interesting. So we really have here 5x over 8 plus 2 minus 4x over 12. Okay, so we can actually, let me rewrite this 2 as a fraction. So let's call it 2 over 1. And let's go ahead and see if we can find an LCD for these 3 values here. And I think they meet at 24 for the first time. So we can do times 3 times 3 times 24 times 24 times 2 times 2. So this one would be 15x over 24 plus 48 over 24 minus 8x over 24. Okay, so just combining some like terms here. Sorry, that was Benny. This 15x minus the 8x is going to be 7x. So we should have 7x plus 48 over 24. That would be as simple as we can go with writing this entire problem. All right. So there you have all 11 problems, including the challenge problems, and hopefully you feel a little bit better about multiplying fractions overall and applying your understanding of it to some application word problems, as well as drawing a model or two here or there as well. All right, so good luck, and I'll see you in the next one.